Hey all of you, hope you guys are great. So in the last video we have completed our check liquidity script. So this is the script we have built in the last video which allow us to check the liquidity. So altogether we have written 6 script which allow us to deploy the contract. So if you haven't followed any one of these tutorials, so make sure to watch that because these are the very vital script which you have to build before we start connecting that. Okay, so we have all the functionality. We are deploying the Uniswap contract, then we are creating the token, then we are deploying the pool, then we are adding the liquidity, then we are checking the liquidity. So we have all these data here. And now what we're going to do is we're going to create 3 more files. So right now you can see that here we have defined hard-coded data, but we need this deploy, pool, check liquidity and add liquidity as a front end. So user can interact with the front end, they can add their information and they can create liquidity. So we can come here and here we're going to create the same file and we're going to do a modification because ultimately we have to connect with the front end and we're going to extract the data from the front end and then we want to make it transaction. So we don't want to go with this hardcode value. So if we come in the pool section here, you can see we have this hardcode value, but we don't want to do that. So we want to make it dynamic. So what I will do, I will simply copy this, and that's what I'm going to paste here. So this is what I'm going to paste. I'm going to copy this, check liquidity, copy that, and that's what I'm going to paste here. Check liquidity and copy this, add liquidity, copy, and that's we're going to paste here. So we have all these 3 script. Now what we're going to do is we have to open it because we have to do a lot of modifications. So instead of modifying every single thing, we're going to rewrite this because modifying will take a lot of time and it's better to write once again everything because we have to do a lot of changes. So I'm going to select this one and I'm going to remove this and save it. Do the same thing for the check liquidity. I'm going to select this, I'm going to remove it and save it, and let's do the same thing for the deploy script. Select one and delete it. So we have these 3 files in our utils. So make sure this is the architecture you have to follow. All the utility function, all the major function we're going to keep inside the utils and we're going to fetch it from here and make it work. So right now we don't need to focus here. So we have these 3 files. We're going to write this script shortly. Now what we have to do is come back to the contract and here we have to do the major changes. So right now you can see if we come to the pop-up token contract, here you can see that here we had defined this function, but I don't want to define this function. I want to initialize my token at the time of token deployment. So if you come here, if you come to this boo token, here you can see this is the method we have used. So this time what I will do, I'm going to simply copy this and this method I'm going to call here. I don't want to initialize with the help of this. So I'll come here, I'll simply paste this, and right now you can see these are the function we have assigned. So simply remove this one. And here we're going to do the major modification. So instead of this, I'm going to pass this the name of the token and pass it, and we have to pass the symbol. So these are the changes we have to do, and from here I'm going to remove this constructor. So now it will work fine, and these are the changes we have to do. Okay, so we have this pop token, we want to create this much token, so this time I will go with 8. Okay, 8. So that's it. Now do one thing, save this one, come back to the Ryan token, and here we have to do the modification. So we don't need this one, replace it, and here we have to change it. So I'm going to call this one is going to be Ryan and this one be the symbol. So paste here and we're going to remove that. So this is our Ryan token. Now simply grab this one more time, and this time 8 is fine. Okay, let's go to the Schwab and we're going to remove this one, and here we're going to simply pass this Schwab, and here we're going to type our symbol, and this time I will go with 6. So all token will have a different quantities. So these are the changes we have to do in all these pop, Ryan and Schwab token. So let me remove this one. That's the one change you have to do in the contract. And now we're going to create one more contract, and in that we're going to keep the data of the user. So just imagine a user will create a liquidity. So once he create the liquidity, so we have to store the information about the liquidity address. We need the 2 token addresses in which he or she has created the liquidity, so we can later fetch those liquidity in our front end. Okay, so for that what we're going to do is I'm going to use a smart contract as a data storage, or in most of the application what will happen that this information you're going to store in an API, or you can store in the smart contract, but I will go with the smart contract approach. So I'll come here, click here, and inside this I'm going to create a new file, and in this file I'm going to call it user storage. So this is the smart contract we have built. Now we have to simply write the contract which can store the information. So let's come back to the swap token, and here we need this. So these are the configuration we need, and we also need this ABI, like ABI decoder, because we're going to use the constructor. And let's build the smart contract very quickly. So we'll come here, we're going to create a contract, and I'm going to call it, let's say, user storage data, and then we're going to define our struct, and inside the struct we're going to call it, let's say transaction struct, and here we have to define the data we want to store. So first data is going to be the address, and this will call caller, so the person who will call the functions, and the second one is going to be the address, and in this time we're going to store the information of pool address, and we have to store the information of the token, so we'll say token address 0, and now the last one data we want to store is the token address 1. So this is our struct for storing the data. Now let's come here, and now we're going to create an array. So we'll say transaction struct, it's going to be an array, and we'll call transactions. So our transaction is right now, we have to create a function to put the data into this struct, into this contract. So we create a function, and we'll call it add to chain. You can call whatever you want. I'll go with add to the blockchain because this is the information I want to store. And first thing, I need the address, and the address of the pool will be the address. So this time would be token address 0, and now we have to take another address, and this will become token 1. So these are the data is coming, and we'll make it public so we can call it. So we got the functions. Now we have to put the data into a struct. So we'll take our array, transaction array, and in that we're going to call this push method, which is available to us, and now we're going to call the struct. So here we're going to call the transaction. So we'll say transaction struct, and inside that I'm going to pass the data. So first data we want to pass is the message.sender, so the one who's calling this. So dot sender, that he becomes the callee. Now let's pass the pool address, and then we have to pass the token 0, and we have to pass the token 1. So this is the function which allows us to give us the data back. Once we load the data into a struct, and you can see things are looking good to me. Now what we can do is, so this function is ready, and I'm getting some sort of error. Let's have a look why this. So it says we have the struct. Okay, let's come down, and here we're going to simply now we have to write a function which allows us to get the entire information, the entire array. So it's very easy. We'll get all transactions. It's going to be a public, and we will say view, and we want to return the information, and then we have to simply return the entire array. So we have the transaction, so we have the transaction struct, and that's what I want to return from here. Will be a memory, and then we have to simply say return, and we want to return the transaction array, and that's it. So this is a smart contract, a very simple smart contract. All it does that it's take this information, so we can store this information into this. Okay, so that's pretty simple. Save it, and now we can simply close this one, and close this one. So make sure you have to do this major changes in the tokens, and you have to create this smart contract. So we are done with this. Now what we can do is, let's come here. We can get into the script, and we can come here in the deploy, and here we're going to simply build a script to deploy the user contract we have created. So what I will do, I will simply come here. I'm going to simply comment this, simply copy this entire contract, make it hide, and here we can come, and we're going to simply deploy this. So this will become the USER user data contract, and here we have to do the modification. So let's come here, we have to get the name of the contract. So this is the name of the contract we have taken, and now we're going to simply pass the name here. So let's select here, tap, and so tab and paste here. Here we have to paste, and here we're going to simply select this and paste, but we have to make it small. And make sure to do these changes, and here we get the address of this contract. So that looks pretty fine to me in the deploy script. We can simply close this one, and now what we can do is, so let's first deploy this contract. So let's come here, let's open up your terminal, and so before we deploy, what we can do is, let's build the script. Okay, let's build the script first. So let me close this, and let me clear all the things. Okay, so things are looking good. So we're not going to deploy right now. First, what we will do is, so we are done with this major changes. So make sure you have to do is, let's come here in the contract. So we have done in these 3 token, we have created this contract. So our script is ready, and we have done the modification in the deploy script. So we can deploy this one, and it's also look fine. And now what we can do is, things are looking pretty good. Now we can come to the utils, and we can start writing the script of this one. So first we're going to write the script for this deploy pool. So come here, we're going to import couple of things. First one is ether, big number, and it's coming from ethers package. Now we have to import the XCS for making an API call, and that's coming from XCS. Now we have to import the Web3 model, and that's coming from Web3 model. Come down, we're gonna create a variable called bn, and in that we're going to use this big.js. And this is the same structure we are following, the structure we have followed in a deploy script. And here we're going to modify the data, but the structure is going to be the same. So I will go a little faster. I'm not going to, I'll go a little faster because we're going to write the same code here. So let's quickly do that. You have to provide the configuration in the big.js package. This is the decimal point I want. Let's come down. We're going to take a variable called Uniswap v3, and we need the contract of the address. So right now I'm going with this previous data, but we're going to change this data when we actually connect the application with the front end. Okay, that's the thing you have to keep in mind. So just go with this data because you have seen that our local blockchain is not running at all. So I'm just taking this hardcode data for the time being. Let's take this one. Now we have to take the fungible manager, and this is the address for my test one. So let me type this very quickly. Let's take a variable. We're going to take the artifacts of these two contract. So we have this Uniswap v3 factory, and that's coming from our Uniswap v3 core artifact contract Uniswap v3 factory.api. So this is the Uniswap v3 factory. Now we have to take a non-fungible position manager. We have to get the ABI of this, and which is inside the periphery artifact contract non-fungible, and we have the API right up here. So these are the two artifacts we are taking. Now let's create the function export const fetch, and this function will allow us to get fetch the contract of this v3 and non-fungible position manager. So let's quickly create the function. In this we're going to provide this signer provider, and we're going to use this new ether contract, and we have to pass the address of the contract. Then we have to pass the ABI, which we have inside the artifact ABI, and then we have to pass the signer. So this is the fetch one, and now we have to build another function which allows us to fetch the other contract, which is a fetching position contract signer or provider. We're going to use this ether.contract, and in that we have to pass the simple non-fungible manager address and the ABI, which we have here inside this position manager, and we have to pass the signer or provider. So these are the two fetching contract function we have created. Now let's come down. We're going to create a variable called encoded price, and this is the same structure we have follow in the deploy pool script, the same script I'm going to write here. So in this we're going to take this two data, reverse 1, reverse 2, and we have to perform this. So we're going to return this big number, and in that we're going to use this big ether.js package. In that we're going to convert it into a string. Then we have to take this div reverse 0, we have to convert it to a string, and we're going to use this method called square, and on that we're going to call this multiply by, and that we're going to pass this bn to convert it to a string. That looks fine. So this is the encoded price. Let's come down. We're going to export a function. So we'll say const connecting with pool contract, and this is the function which allow us to connect. So we'll call this function in the front end, and in this we're going to pass couple of data. So it's going to be an async function. So in that we're going to pass this first data. First we'll pass the address of the first token, then we have to pass the address of the second token, then we have to pass the fee we want to charge, and we will have to take the token fee, the price we want to assign to the token. So this is the first price for the token. Now we have to take the second token, and that's it. So these are the data we're going to take into this connecting with pool contracts. Okay, so let's come here. We're going to call this, and in that we're going to simply take a variable because we need a provider. So we'll say web3 model, and we have to take our provider, which we have here. Now we have to build the connections, and we can easily able to do that, web3.connect, and now we have to build the provider. So we'll say new ether.provider.web3 model, in that we have to pass the connection. So same old school we are following here. Let's come down. We're going to take another variable. We'll say signer, because we need a signer to perform the transaction when we transfer the token. So we'll say get signer. So we'll have the signer. Let's come down. We're going to take a console log. So let's see what we'll get. Let's come down here. We're going to take a variable called create pool contract, and we have to create the contract. So we'll say await fetch position contract. So this is the function we have created. In that we have to pass the signer. So this will give us the contract of this create pool contract. And come down, we'll take another one, price, and we're going to store the price here in this variable, price variable, and we're going to call the function. In that we're going to pass this token 1 fee and token 2 fee, because this is the price user will going to assign. We'll console log out the price. So let's come down, we're going to take a variable called transaction await create. So here we have our create pool contract, and in that we have to simply call this connect method. So we have the transaction, so we have the signer. So that's what we have to use to connect, because if I'm doing the transaction, so I will be the signer, and here I'm going to call the function. So we'll have this function create and initialize pool necessary, and in that we're going to pass the address of the 2 token and the fee and the price. So these are the 3 data we are passing, and we have to assign the gas fee. This gas fee is the recommended one, because if you go beyond this, it will say you that you have assigned too much gas fee. So this is the recommended one in the middle. So this is the initialize function. Let's come down here, we're going to await. We have to wait for the transaction to be completed. Now let's come down, we're going to take another variable, we'll say factory, and we have to do the same thing for the factory, because this factory will give us the data of the pool we have created. So let's fetch the contract, we'll pass the signer, and once we have the signer, we have to get this pool address which we have in this. So we'll say factory.get pool address of the 2 token, and we have to pass the price. When we pass these 3 data like token 1 and token 2 and the fee in our get pool function which we have inside the factory, it will give us the address. So make sure these are the exact data you have to provide, because if you provide different pool fee, instead of 3, if you provide 5, you will get an error. You will not get the address of that particular pool, because same token can have a different pool fee. So that's the key point you have to keep in mind. Let's come here, we can return the pool address from these functions, and that's it. So you have seen we have written all these functions. So we have this import, we have this big number JS, we have the contract addresses. So right now we have hard coded this, but we're going to make it dynamic. This is the artifact we have, this is the pool fetch pool contract, this is the position contract, and this is the price, this is the connecting pool contract functions, and we are doing this, and at the end we'll get the address. And this address is very important, because we need this address to create liquidity. First we'll initialize the pool. Once the pool is ready, then we're going to create liquidity, and that's how the Uniswap smart contract exactly work. So right now we're not going to deploy, we already know that it's working fine, because we have to connect this and it's working fine. So let's close this one, and now we can start working on our add liquidity. And now we can start working on our add liquidity script, and after that we're going to work on the check liquidity. So we have to modify this entire add liquidity script we have written into a connectable format, so the user can provide and create liquidity. So let's create this. So first thing we're going to do a couple of imports. We need Web3 model, and that's coming from Web3. Then we need the, let's say, contract ethers, and that coming from the ether package. Now we have to import the token, and that's coming from Uniswap SDK core. We have to import the pool, positions, and nearest usable tick, and that's coming from our Uniswap v3 SDK. Let's come down here, we're going to write the Uniswap contract addresses. Here I'm going with the demo addresses, but later we're going to change this addresses with a real one. So let's build the functionality, and later we're going to simply change the address. So we have all this address, and let's come down here, we're going to take our artifact which we have inside this first artifact. We need this non-fungible position manager, and it's coming from the same place. So let me quickly write this. So here we have the artifact, we have the non-fungible position manager, and we have the Uniswap v3 Pro. So let's start working. Let's come on, we have to create a function, async function, and we'll say get pool data. So this function will allow us to get the data of the particular pool. So, and that pool address we're going to pass here. So we'll say pool contract, inside that we're going to take a variable called tick spacing, fee, liquidity, slot 0, and it's coming from promise.all. And in that we're going to make the function call. So we have the contract, and on that contract we're going to make this function call. So first is going to be the tick spacing, second one is going to be the pool contract.fee, and third one is going to be the pool contract dot liquidity, and the last one is going to be the slot 0. So these are the data we are getting from here, and let's come down here. We're going to return that. So the data I want to return is this tick spacing. It will say tick spacing, and now we have to take the fee, we have to ready. Now we have to take the square price which we have inside the slot 0, then we have to take the tick which we have in 1, and that these are the data we are returning, and these are the data we are returning from this function. So let's come down here. We're going to take a function called export const add liquidity external, and this function we're going to attach in our front end to take the data and create a liquidity. So it's going to be an async function, and in that we're going to take this data. So first data we need the token address 1, second data we need the token address 2, third one is the pool addresses, because first the pool will get generated, after that we're going to use that pool to create a liquidity. So we have the pool address. Now we're going to take this pool fee, we're going to take this pool amount 1, that how much amount we want to provide as a liquidity. So that's amount for one token, and we have to take the other token first, second, and these are the data we are getting into this function. Now let's come here. Here we're going to build this const, we need a provider, so let's build our provider Web3 model. Then we have to build the connection, await Web3 model connect. Once we have the connection, we have to create the provider, and we'll call it provider Web3 model. In that we have to pass the connection. So that looks pretty fine. Let's come here, take a signer, and we have get signer. So we have all these crucial important data which allow us to interact with the wallet. So we'll take a variable, we'll say account address, and we have to get the address of that account because we need to transfer the funds. So when we do the transfer of the funds, we need to assign the address where we want to receive the fund. Okay, so we have the address. Now let's come here. Here we're going to take this const token contracts, and now we have to get the token contract to get the information of the token which we can utilize to provide a chain IG symbol name. So we need information. So let's get the token contract, and we have addresses of the token. We already have the address, and in that we have to pass the ABI which we have inside this Weth9. So this is the package which we have installed, and that's what we have here, Weth9, and we're going to pass this provider. So that looks pretty fine to me. We have the first contract. Now let's come here, we'll take the second contract, and we're going to pass the token address 1. We have to pass the artifact which we have inside this weth9.abi, and we have to simply pass the provider. So that looks pretty fine to me. Let's come here. Here we're going to take this await token 1 contract, and now it's time to get the data. So first we're going to simply connect the signer, and now we're going to make a call. So first thing we have to do is to approve position manager. So it's going to spend the token on behalf of us. So we have to provide the amount. So here we're going to provide the amount the user is providing, and we have to convert it into a string. I believe these things are making sense. This is a very generic function we are writing and function calls we are making. So this is the contract 1. Now we have to do the same thing for the contract 2. So we'll say contract 2, we're gonna pass this, connect the first signer, and then you have to approve the position manager address, and then we have to assign the amount. So which we have ether.utils.parse ether. In that we have to send the second amount and convert it into string. So these are the approval we are giving to the position manager. Let's come down. Here we're going to create a const. We'll say pool contract. So we have the address of the pool. We're going to utilize that pool address to get the contract. So let's come here. Here we're going to say contract, and then we have to pass the pool address. Inside the pool address we have to pass the artifact. So we have into this Uniswap v3 pool, and this Uniswap v3 pool contain all the information about the pools. And here we're going to pass the provider. So in this way we can easily able to get the pool contract. Let's come down. Here we're going to take another variable. In that we're going to get the chain ID. So which network we are connected. So if you talk about mainnet, it's 1. If you talk about Gorilla, Test, so they have different chain ID. If you talk about the local host, it's had different. So, and this data is coming from here. So we have a provider, and that we're going to call this get network, and this will give us the chain ID. So get network will return an array, and from there we are extracting the chain ID. So that's the chain ID we have. Let's take a variable token 1, and we have to extract couple of information from the token, because we need the information of the token. To token we want to provide liquidity. So this is the first, we need the token name, and we have a function called, this is the contract. We have token 1 contract, and in that we're going to call this name functions. This will give it the name. Do the same thing for the symbol. We have to give the contract and we have to call the symbol functions. Do the same thing for the decimal point, because not all the token going to have the same decimal point. Some will have 18, some will have 9, some will have 16. Okay, so they have different decimal points, so that's why we cannot go with a hard code value. We're going to fetch the information on the base of the user selections and get the decimal data so we can make the liquidity happen. Here we're going to call this token dot decimals, and now we have to get the address of this token, which we have inside this. So we'll say await contract dot address. You can simply get it from the contract, or you can get it from the functions where the user is providing these information, the token addresses. So that looks fine to me. Let's come here, do the same thing for the other token. Token 2, we have to get the name, and this data we have inside name, then symbol. We have to take this token 2 contract and we have to call the symbols. Do the same for the decimal points. Await token 2 contract dots decimal point, and we have the address. So to address is token 2 contract dot address. So we got the address of both the tokens. So that looks pretty fine. Make sure to do all of these. Now let's come take a variable. We'll say token A, and here we're going to call the token function which available in the SDK to get the information. And it's nothing new to all of you guys. We have already done this when we were building the script in the liquidity section, adding liquidity section. We are just modifying the data. So we'll call this new token, and in that we have to pass the information. So we have the information. First thing, we have to pass the chain ID, then we have to pass the token addresses, then third we have to pass the token decimal, then we have to pass the token name, then we have to pass the token symbol. So these are the data, it's must. And the reason why we are using this function, because we want to display the information in the front end. So this is the first token. We have to do the same thing for the other token. So this will become token B, new, and we have to pass the relevant information, chain ID, second token address, decimal point of the second token, name of the second token, and symbol of the second token. So that looks pretty good. So we have this information. Now we can come here, and here we're going to take a variable, say pool data, and here we're going to call the function, so get pool data. So this is the function we have created at the top, and in that we're going to pass the pool contract, and now we can easily able to get the data. So we'll say console pool data, so we can check. And now let's come here. Here we're going to take this variable, we'll say pool, and we'll call new pool. In that we're going to simply call this token A, token B, and we have to take this pool data fee, because this pool data will contain all the information. Here we're going to say pool data square, and we have to convert it into a string. We have to say pool data liquidity, convert it to a string. We have this pool data tick. We have come down here, we're going to take a variable called position, and we'll say new position. It's going to be an object. Inside that we have to take this pool, we have to take this liquidity, provide this value. So right now I'm going with this hardcode value of the pricing. So I'm going with the hardcode value. If you want, you can make it, this one is also optimized or a user input, but just go like this for a time being, and later we can definitely come and change it. So let's come here. We're gonna take this tick, lower tick, and we have to assign the lower tick nearest usable tick pool data. We pool tick spacing minus pool data dot tick spacing multiply by 2. So, and do the same thing for the lower tick as well, so upper tick as well. So first we have done with the minus, now we have to do with the plus. So in that we're going to add it the same exact amount. So pool data dot tick spacing multiply by 2. So it will be always in the range. So these are the information we are assigning to the positions. Now let's come down. Here we're going to create another variable, in that we need the amount, and this amount is coming from there. So we have this desirable, one amount, and we have this position dot mint amount. So this will give us the amount of the desirable. So we have this one. Now we can come down, we're going to take another variable, we'll say params, and we have to build the entire params which we want to pass to provide a liquidity. So let's come here. Here we're going to take a token 1, this will become the token 2, then we have to take this fee, and that's we have inside the pool data fee. Then we have to take the tick, lower tick, and the same nearest usable tick we have to assign. So ticks pool data spacing, we have to say minus, and we have to say pool data dot tick spacing multiply by 2. To do the same thing for the upper tick, tick spacing, and we have to simply go with the upper value, tick spacing multiply by 2. So this is the lower and upper tick we have to assign the amount. Desired amount is going to be the amount, convert it to a string. Do the same thing for the other desirable, number one, sorry, and convert it to a string. Let's come here. We have to define the min is going to be a 0, and max min is going to be 0 for both the token. Then recipient is going to be the account address. So this is the account address we have taken at the top, and that's going to be the recipient. Let's come here, and we're going to say deadline. So this data is going to be, so right now I'm going with the hardcode value, but you can make it, this one is dynamic, but in the industry this is the recommended standard deadline time is assigned, so that's why I'm going with 10 minutes, not more than that. But later if you want, you can make it dynamic as well, but let's go with the 10 minutes. And that's the entire params we have. Now let's come here. We're going to take another variable. We'll say non-fungible position manager. So we have to get this contract, and we have this contract. Inside that we have to pass the address of the contract. So we already have it at the top, position managers. So right now we have hard coded this data, but we're going to add the real addresses. When we deploy the contract and get the real address, that's what we're going to assign. So we have this address, position manager address. Now we have to assign the artifact, non-fungible position manager, and we have the ABI in that. Let's assign the provider. So we already have the provider. So this will give us the contract of non-fungible position manager. Let's come down, and here we're going to take another variable, and now we have to make the transaction. So we'll say non-fungible position manager. We're going to say connect. We have to connect with the signer, and we have to call this mint function. In that we're going to pass this params, and we have to pass the gas limit. And this time I will go with this number, and that looks fine. Let's take another variable, and that we're going to take this recipient, and we have to say await dot, so we have to wait till the transaction get completed. Once we have this recipient, all the information about the transactions, in that we're going to simply return that from this function, and that's it. So we are done with this entire add liquidity functionality. So these are the hard-coded demo data we have taken for this contract, but we're going to replace with this actual one. This is the artifact we have, this is the pool data, this is the liquidity functions, and we have written so many codes. So hope this entire things makes sense to all of you. If you still have any confusion, any doubt, do let me know in the comment section. Now let's write the last and final script, which is this one, check liquidity. So first thing, we have to import couple of things, Web3 model, and that's coming from Web3, and then we have to import the Uniswap v3 pool, and that's coming from the packages we have installed, v3 core artifact contract Uniswap v3 soul, and we have the ABI, which is a JSON. Now we have to import the contract ethers, and that's coming from the ether package. We have to import the pool, and it's coming from the Uniswap v3 SDK. Now we have to import the token, and it's coming from the SDK core. Now we have to import the ERC20 interface, and that's we have inside the context ERC20 JSON. So I hope you guys can make the sense that from where I'm getting all these values. So that's fine. Let's come here. Here we're going to create a function, async function, and that we're going to say get pool data, and that we're going to pass the pool contract token address and token address 2. So these are the two addresses of the token we're going to assign, and it will give us the pool data. So here we're going to take a variable, and in that we have to pass this tick spacing, we need the fee, we need the liquidity, we need the slot 0, and we need the factory, we need the token 0, we need the token 1, and we need the max liquidity per tick, and these are the data we need. So we're going to call this wait promise.all, and we're going to simply call this. So we have the contract, in that we're going to call all of these functions. So tick spacing, fee, we'll call the liquidity, we'll call the slot, pool contract.slot, we have to get the factory, we have to get the token 1, we have to get the token 2, sorry, token 0 and token 1. Now we have to get the pool contract, max liquidity per tick, and these are the data we are returning. Let's come down here. We're going to take a variable called Web3 model because we need to get a provider. Then we have to build the connections. So await Web3 model dot connect. We have to get the provider, and here we're going to call this new ether dot provider dot web3 provider, and then we have to pass the connections. Let's come down. We're going to take this const token contract 1. Now we have to get the first token contract. So token 0 contract, we're going to call this, pass the address of the token, pass the ERC20, which is the ABA, and the provider. This will give us the token contract. Do the same thing for the other token. So this will say address to ERC20 and provider. So those two token contracts we have here. We'll come down here. We're going to call this chain ID because we need to get the information, and for that we need to have a chain ID. So this chain ID is coming from provider dot get new network, get network, and here we're going to use this token, and here we're going to assign the token information to our token functions which we have imported from the SDK. So let's do that quickly. So we'll say const token 0, it's gonna be await token contract dot name. Let me write it very quickly. Let's come here. Here we're going to take a variable called token A, and in that we're going to pass this. We have to pass the chain ID, we have to pass the address, we have to pass the decimal point, we have to pass the token symbol, and we have to pass the name. Do the same thing for the token B. So these are the token A, token B we have done. Let's come down. Now we have to take this const pool example, and we're going to call this new pool, and in that we're going to pass this token A, token B. We have to take the fee, we have to call the slot string, liquidity string, slot 1. So these are the data we are passing into our new pool. Let's come down. Here we're going to take a return the data. So the data we want to return is the factory, and we want to return the token 1 0 and token 1. We want to return the max liquidity per tick. Now we want to return the tick spacing, and we want to return the fee, we want to return the liquidity. We have to convert it to a string. Now we have to import the square price slot 0, import the tick which we have in slot 1, import the observant index which we have in slot 2, and we have this observant credentiality slot 3, we have this observant next slot 4, and we have this fee protocol to 5, and unlock we have this 6, and at the end we're going to receive this entire pool example data. So that looks pretty fine, and now close this one. So these are the data we are receiving from here. Now we can come down. We're going to create another function called export, and this function we're going to call on the front end. So get liquidity data, and that we have to pass a couple of data. So we have to pass the pool address to get the liquidity data and the two token addresses, token 1, token 2, and we will get the data. So let's come here. We'll create a variable. We need a provider, so let's build the provider. So we got our provider. Now we're going to take this pool contract, and in that we're going to pass the data. So we'll pass the pool address, we'll pass the Uniswap v3 API, and we have to pass the provider. So we'll give it the pool contract, and in the pool contract we're going to call this pool data, and here we're going to call the pool data. Inside that we're going to pass this pool contract, so it will give us all the data. Okay, same logic we are following here. Pool contract, and we have to pass the pool address 1, and we have to pass the pool address 2. That's it. Let's come down. Here we're going to simply return the pool data, and that's it. So here we have modified the entire check liquidity function. So now we can call this function in our front end. So hope this entire thing makes sense, because the same thing we have, so the same logic we have follow here. We have done a major modification to make it usable at the front end. Token information can be fetched through this function. So hope this entire thing makes sense to all of you guys, and these are the major things we have done, and now we can start working on our context.